Hello US, this is Yashwant from Mahindra University, Hyderabad, and I'm currently pursuing my first year of MTech in Computer-Aided Structural Engineering, and I'm here today with my teammate Sharat Chandra to present a course project on assessment of self-healing concrete using a piezoelectric sensor. And this project is under the guidance of Professor Vishalakshi Talkokula, and this project is for the course of Infrastructural Health Monitoring. And this is a list of the contents which we are going to focus in this presentation. Structural health monitoring is a very diverse field where an engineer usually focuses on the continuous and periodic assessment of a structure, which helps us to know the integrity and performance of that structure. And this helps us to ensure the safety, performance, and increase the lifespan of that particular structure by detecting the damages early. And we can integrate this in the civil engineering, and we can detect the early crack formation and corrosion in the reinforcement of the structure and any other structural weaknesses, and we can also take some proactive maintenance such that the lifespan of the structure is increased. And monitoring will definitely help us to prevent catastrophic failures by identifying the potential hazard before they are escalated. And there is a very urgent need for incorporating structural health monitoring in infrastructure management, because as we know that concrete structures which are constructed in the early 70s and 80s are very heavy structures. They are they are in deterioration stage, and they need to be monitored diligently so that they may not be very heavy casualties or human toll. And we can also see the increased spending in infrastructure maintenance. As you can see here, US alone is spending around 490 billion in operation and maintenance in 2023 financial year. And if you have seen it in 2015, it was about 250 billion. This is a very huge market, and also we can see that by tapping into this market perfectly, we can actually reduce the cost which we generally spend for maintenance, and now by diligently monitoring it. And we think that self-healing concrete can also help reduce the cost by minimizing the frequency and severity of the repairs which are to be needed. And some studies have also shown that predictive maintenance, which can be enhanced by self-healing materials, can decrease the maintenance cost by about 12% and extend the lifetime of their aging assets by about 20%. And this can see, this study has demonstrated the financial viability and long-term benefits of adopting the advanced materials self-healing concrete into the infrastructure, and also by continuously monitoring with the help of structural health monitoring techniques. The objective of our study is to integrate the systems which combine self-healing concrete with the structural health monitoring, and we aim to identify the minor changes which happen in the structure due to the activity of self-healing inside the concrete. And the methodology and the approach which are going to take in this project are further explained by Sharat.
Hello viewers, this is Sharat Chandra. Coming to the methodology, first we have to prepare the materials, what are the quantities that we require. Then we have to cast the concrete specimens, and then we have to induce control damage. Here we will be discussing about the material preparation and damage in the coming slides, and then we are going to integrate the sensors, and then we are going to calibrate the sensors, and then we are going to measure the baseline data. Once we are done with this, here comes the bacteria part. First we have to culture the bacteria, we have to revive the bacteria, and then we have to culture the bacteria, and then induce the bacteria into the test specimens. Then we have to monitor, and then data analysis, comparison with the baseline data which we have taken already, and then validation part. Coming to the reviving of bacteria, first we have to revive the bacteria, and with the help of LB agar, and then we have to keep it for overnight culture every day. And once the bacteria is grown, we have to take OD 600 reading with the help of spectrophotometry, and then we will centrifuge and then dilute it to the 1 into 10 to the power of 8 per cells per ml, and then we dilute it with the buffer solution and place it in the cracks. Here we have taken two kinds of bacteria, which is the family of Bacillus. One is Bacillus megaterium and other is Bacillus subtilis. Bacillus megaterium is kept in an incubator at 37 degrees centigrade and Bacillus subtilis in 30 degrees centigrade. We have also made Bacillus megaterium spores. Generally, spores are nothing but when we give a harsh condition to the bacteria, it forms a protecting layer over the cell, which is called a spore. So here the for this megatherium, we have given the harsh condition as the low. We have given food for 1 day and we have kept it for 7 days, which made the cells into spores. Generally, this is used for uh, helping the bacteria in sustaining in the harsh conditions. In our criteria, harsh condition is the high pH value of the concrete, which is 12 to 14, and these are the materials that we used. First is the cement, fine aggregate, polycarboxylate ether, which is a super plasticizer. We have placed the specimens in a petri dishes, which is of 90 dia and 15 height. The Bacillus subtilis and Bacillus megaterium are the bacteria which we have taken. LCR meter is used to take the frequency readings, and PZT sensor is the sensor which we have used. This is the mix design and the proportions. As you can see, number of petri dishes are 22. We have considered the M40 grade of concrete, OPC 53 cement, water to cement ratio is 0.3, and sand to cement ratio is 2.75, and superplaster dosage is 0.3 percentage. And here you can see these are the quantities that we got. Cement of 1 kg, fine aggregate which is passing through 0.6 mm is 3 kgs, SP dosage is 3 grams, and using water we have cured it for 28 days. And once we place the concrete in the petri dishes, then we are going to induce a crack. Here we have induced cracks in different criteria. So these are the crack dimensions. Here we have considered length and depth as constant, and width is keep on increasing. We have considered 0.5, 1, 1.5 and 2 mm of cracks. These are the sensors. These are small piezoelectric sensors which is of 10 by 10 size. This is actually used for very high sensitive sensor. And here you can see this is a picture of surface bonded PZT, and this is the picture of epoxy coated, and the further will be explained by Yashwant.
We've got our pause, okay, yeah. So we got our cultures from MTCC, and in general MTCC supplies the culture in a freeze and dried state, in a dried state form. So we received the culture in such manner, and this is how we revived our culture. Once we got our culture from the MTCC, we grew them in petri dishes with soya agar, and we can see the formation of bacteria colonies. And with the help of these bacterial colonies, we prepared some overnight culture in the media made with soya broth, urea, and ammonium bicarbonate. And once the overnight culture is grown, we calculate the density of the bacteria with the help of OD600, which is known as optical density at the wavelength of 600. And with the help of absorbance, we get to know the concentration of bacteria. We adjust the concentration of the bacteria by centrifuging it and adding a buffer solution. The buffer solution is usually there to protect the bacteria which are going to be induced in a high alkaline environment, which are concrete specimens. And the reason for us to choose the bacillus bacteria is because the bacillus bacteria usually show a property known as biomineralization. um, Biomineralization is a property which is exhibited by microorganisms, where a small microcrystals are deposited in the matrix of the living organisms. And this deposition of the minerals, which in our case is calcium carbonate, is is very helpful in healing the concrete. And that is the reason why we choose bacillus bacteria. Coming to the experimental setup, we can see here we use vPro software and an LCR meter to get our signatures from the test specimens, and the sensors are actually strategically fixed in critical locations which are very near to the crack of the motor specimen, and and the operating frequency of the LCR meter which we used was from 30 kilohertz to 400 kilohertz with a step size of 100 kilohertz, with a step size of 100 hertz, and we generally added the bacteria for every 24 hours and incubated the specimens for at 30 degrees centigrade. And while coming to the Bacillus megaterium, we actually created some spores by subjecting them to harsh conditions, and we pasteurized them to kill the vegetative cells, and then we added the spores only once, and we kept them at an incubation temperature of 37 degrees. And coming to the qualitative assessment of the damage, we used electromagnetic impedance technique, where the impedance of a structure, which is directly related to the modal parameters like the mode shapes, mass, and the stiffness of the structure, is calculated with the help of electrical and mechanical signals. So in this technique, generally the the interaction between the electrical and mechanical properties of structures are changed when there are some then when there are some certain anomalies which are created in the structure, or which appear in the structure due to the change of internal structures. In our structures, due to the bacterial action, there will definitely be a change in the internal structure of the in the internal properties of the structure, which will further change the signature of the structure. And for this, we have used a small high sensitivity PZT, and the sensor is typically used to measure the impedance, as I said, the modal parameters. And by analyzing the shifts in the impedance signature, we can possibly identify the presence of damage or the ongoing self-healing process, and ensuring the integrity and long life of the structure. Or we can also say that the activity of the bacteria is being captured by the continuous change in signal of the structure. And the further part and the results are discussed by Sharath.
One just now said, it is a qualitative assessment of the healing of the concrete. Here we can see this is the 0.5 mm crack of Bacillus megaterium. We can see the peaks are upshifting. It's not that it is upshifting or downshifting, it is just a qualitative assessment of is there any change in the signature or not. Here we can clearly see that there is a change in signature, which qualitatively say that there is something happening inside the concrete, which is what the qualitative assessment says, but it doesn't says whether it is because of the healing of the concrete or maybe because of some other reactions. um, this is the 0.5 mm crack uh, acquired data, and here also we can see for 1 mm data there is a shift in the signature, and this is the 1.5 mm crack signature, and this is a 2 mm signature. So in all these signatures you can see there is a shift in the signature, which says that there is some material which is filling, or maybe some reaction which is happening. Here we have induced the bacteria after curing for 28 days, and then um, we have induced the bacteria. So it says that in generally reaction happens within the 28 days, which is because of hydration. So after 28 days, the most of the reaction is because of something which we add externally, and internally there won't be any reaction. So this is the 0.5 mm crack of Bacillus subtilis, and here also we can see there is some shift in the signature that we acquired, and this is the 1 mm subtilis, and this is a 1.5 mm crack which we induced Bacillus subtilis, and as you can see there is some shift in the signature. So in all these signatures we can see there is some shift which says there is something happening inside the bacteria, but we don't know whether it is because of the bacteria which we add or not. And we don't know that how much amount of healing is happening inside the concrete. So that's why we have also done quantitative assessment, which is using root mean square deviation, which is also called as RMSD. Generally this RMSD will give us a the percentage of change between the baseline data and data which you have acquired. So here we can see for zero point 0.5, 1 and 1.5 mm and 2 mm cracks, the RMSD is changing, which says that there is some change. But as I said, though this is a quantitative analysis, we haven't got the exact amount of healing, how much it is happening. And there you can see at day 7, there is a maximum shift in all the RMSD values. And then we thought this might be the case which healing is happening. And then when we plotted for subtleties, it is totally different. It came at day 10, the RMSD value is reducing. Then we opted titration method, which will be explained by Yashwant. And here in this picture you can see this is a zero point 0.5 mm crack. We have acquired the data for 15 days, and you can see there are some white uh, deposits which is inside the crack. So this is because of CaCO3. Generally in concrete, calcium is present because of cement, and CO2 from the outside and OH ions will combinedly form HCO3, and at more than pH 9, HCO3 will divide into CO3 2 minus and H plus ions. As we know, concrete is more alkaline in nature, and its pH is around 12 to 14. H plus ions will be removed from the HCO3, and this remaining CO3 2 minus is then reacted with the calcium which is present inside the concrete and forms CaCO3. And this is how CaCO3 is formed, and we can see there are some white patches inside the concrete, which says there is some result which is showing, but we don't know whether it is healed, how much amount of healing is happening inside the concrete. So then we have opted titration analysis, which will be explained by Yashwant.
To ensure that the change in signature in the specimens is really due to the bacterial action, and the change in RMSD value is also due to the bacterial action and the formation of calcium carbonate. We have validated the study or our observations with a simple calcium carbonate equivalent test or a titrometric method. In general, this is used to calculate the calcium carbonate content in soil, but here we have used it to calculate the excess carbon, to calculate the calcium carbonate digestion with the help of excess acid in our concrete specimen. We crushed our test specimen, and we made it into a made it into a very fine powder. And by assuming that, or in general, the two equivalent parts of acid or HCl can react with 1 mole of calcium carbonate, and therefore we can say that one equivalent part of acid can be react to a half mole of calcium carbonate. And to get this and to calculate the calcium carbonate value in the sample, we applied the following formula, where where we can see that VHCl is a volume of the HCl, and N is a normality. And Firstly, we standardize the normality of the HCl and NaOH, or the sodium hydroxide, and the standardized normality of hydrochloric acid is for 0.4 normality and normal, and the sodium hydroxide is 2.43 normal. And for this test, we took a sample of 10 grams of cement, and for that we added 20 ml of HCl. And after thoroughly mixing the HCl and boiling the solution, we added around 100 ml of water to the solution, and then it was titrated in sodium hydroxide until the current color change is indicated, which we can see in the picture. And and the change in color has indicated the end of the titration. And with the changes and with the changes in the volume of the NaOH used, we calculate the percentage of CaCO3 with the help of the formula which we have seen in the previous slide. So by the help of the titration, we got the results for a sample in which there was no bacteria, and other sample where the bacteria subtilis is placed, and the weight of the sample which we have taken are 10 grams and 5 grams. And we can see, according to the weight of the sample, the volume of the HCl used and the volume of NaH which was used up for the titration to be completed. And we can see that the results are here, and we omitted odd one out, which was showing some different results. And we can see here that the sample without bacteria has a calcium carbonate percentage of 2.78, and the sample with bacteria, the calcium carbonate percentage is about 6.65%, which indicated that the change in signatures is indeed due to the formation of calcium carbonate by the bacterial action. And therefore the titration test has concluded that there is an increase in the calcium carbonate percentage, and that is due to the presence of bacteria and the bacterial action. So by this we can say that the project has demonstrated the successful integration of the structural health monitoring techniques by using the electrical impedance technique, and has noted the minute changes which are caused by the bacterial action. And the application of the self-healing concrete, we can also use it for the prolonged life of the structures, and for a promising maintenance and enhanced durability of the critical structures as well. And the structural health monitoring, with the help of this approach or the innovative approach, it not only improves the safety and the reliability, but also offers a sustainable and a cost-effective method for the infrastructural maintenance. And the future research and development can further optimize this system, paving a way for a widespread adaptation and some innovative engineering applications as well. These are some of the references and the journal papers which helped us throughout the study, and helped us in culturing bacteria, and also helped us how to approach the project. And we are very thankful for them. This is a small acknowledgement from our side for our professors and the teaching assistant who helped us in the journey of this project. Professor Vishalakshi Talakokula and Professor Mritika Sen Gupta, who helped us in approaching the project, and also the culturing of bacteria. And the teaching assistants Ramesh Gomasa and Anupriya, who were part of the projects, and helped us with the acquiring of the data, and also in the biotechnology laboratory, and also in the validation process, which is the titrometric process. And we are very thankful for them for their patience and dedication, which have been very instrumental for the success of the project. I thank the viewers who have patiently listened to our project, and with this I would like to conclude my project. Thank you.